I would like to begin today by just reviewing some our power rule for derivatives. If we have x to the n in our integrand, what will be that antiderivative? Well, we raise the power by 1 and then divide by our new power, right? Does that work for all n's? If you recall, I said that when we talked about the power rule, I said that this rule is good for every n except -1. So what happens if n is -1? If n was -1, then we would have that integral antiderivative. So I could rewrite that to look like this, yeah? Yeah. So what would happen if we tried to apply the power rule on this one? If we tried to apply the power rule, we would add 1 to the power. If I added 1 to the power, that would make my power 0, and then I would divide by my new power, and that's the problem right there. That is the problem. We cannot divide by 0. That's why this is true. That will not work. So let's think of this with the thought of what function do we take the derivative of to get 1 over x? Which function's derivative is 1 over x? It is the natural log. So that is what we're doing today. We're going to be integrating 1 over x, and we will get the natural log. So the antiderivative of 1 over x is ln of x plus c. However, we don't usually talk about domain in calculus, but it is always in the background. The domain of this function, of this expression that we are starting with, this domain is all real numbers except 0, right? What's the domain of our answer? The domain of our answer is not the same as the domain of what we started with, because the argument of a natural log must be positive. So we make this have absolute values, and now it is correct. The antiderivative of 1 over x is ln of the absolute value of x plus c. All right? Notice that if there's only a 1 on top, well, no matter if there's a 1 or anything on top, you can multiply this dx to the top, right? So oftentimes, instead of writing 1 over x dx, we will write just dx over x. Okay? Oftentimes, we need to use u sub. It won't just be 1 over x. It'll be 1 over something else that we need to do a u sub with. If we do a u sub, we're going to get an integral that looks like this. Okay? And so the antiderivative of du over u will be ln absolute value u plus c. Okay? So what is the derivative of ln of u? The derivative with respect to x of ln of u is u prime over u. What is u prime? U prime is the derivative of u, right? Which is exactly what we have here. U prime actually means the derivative of u. Okay? With respect to u. Alright? So, makes perfect sense. Alright, so, summarizing here. If you have an integral, if your denominator is linear, do not bring it to the top. Do not give it a negative power. Instead, leave it on the bottom, do a natural log. Okay? Kids get very used to doing this, and they want to do it for everything. But the denominator must be linear, and no x's on top. Linear bottom, no x's on top. That's when you get a natural log. So let's look at some examples here. First example. Linear bottom, the power is 1. Linear bottom, no x's on top. This is going to be a natural log. However, we need to do a u sub first because it's not a plain x. So I let u be the bottom. du is 1 dx. So dx is just du. And we get the integral of du over u, which is ln absolute value u plus c. Go back to your x's, ln absolute value x plus 10 plus c. So I'm going to keep track of a summary here. The integral of 1 over x plus 10 is ln absolute value x plus 10 plus c. Okay, let's do this one. The bottom is linear and there are no x's on top. So this will be an ln, except it's not a plain x, so we do a u sub. U is 3x minus 7. du is 3 dx. So I need a 3 on top with the dx, and then I will get my du. So I will need a 1/3 out in front, and we get 1/3 integral du over u, which is 1/3 ln absolute value 3x minus 7 plus c. Oops, I was going to put in u first and then put in my x's, but I jumped the gun and put in my x's right away, which I usually do, because it is ln of u. So ln of u, right? So we found out, I'm just going to rewrite this down here, the integral of 1 over 3x minus 7 dx is 1/3 ln absolute value 3x minus 7 plus c. Okay, what pattern do you see here? What pattern do you see? Where did this 1 over 3 come from? Where did the 3 come from? And why didn't we have it up here? The derivative of this denominator is 1. So it's like you have a 1 over 1 out in front. The derivative of this denominator is 3. So you have a 1 over 3 out in front. If you take the derivative of this, you do get back that. So let's use that pattern on the next one. Okay. All right. First of all, I do see this 9 up on top, which does not bother me. If it's on top, it just comes right out. So this is the same thing as 1 over 5 minus 4x dx. Linear denominator, no x is on top. So this will be an ln. This is an ln of the bottom. ln of the bottom, because the bottom is linear. In front, though, we have 1 over the derivative of the bottom. What is the derivative of the bottom? Negative 4. So this is negative 1/4 ln absolute value 5 minus 4x plus c. Number 4 here. Linear denominator, no x's on top. So this will be an ln. ln absolute value of the bottom. Okay. What's the derivative of the bottom? Negative 1. So this will be 6 over negative 1 as the coefficient. The 6 just stays on top. So this would be negative 6 ln absolute value 2x, or 2 minus x plus c. Alright, number 5. Number 5, is the denominator linear? No, it is not. So immediately, this is not an ln. However, after we do a u sub, we might get an ln. Let's do a u sub. Let's let u be the entire denominator. U is the entire denominator. Because remember, we would like to get du over u. So u is the entire denominator. What is du then? Negative 2x dx. The x dx, the x is there, it's the Santa, it's Santa's present, right? We need a negative 2 with it, so I'm going to multiply by negative 1/2 outside. So this is negative 1/2 integral, there's my du over u, and now it's a natural log. So negative 1/2 ln absolute value of u, which is 2 minus x squared plus c. Okay? So we found out there that the integral of x over 2 minus x squared dx is negative 1/2 ln of the bottom. So think about that. Ask yourself, what was the pattern there? Because Santa had that present of an x, it did become an ln. It didn't start looking like an ln. If that x was not there, would it have been an ln? No, it would not have been. Okay? Number 6. Again, the bottom is not linear. So initially this is not an ln. It's not a du, it's not a 1 over x dx, right? So I'm asking myself, could I make it be that? If I let u be the entire bottom, could its derivative be something that's on top? That's what I'm asking. Could its derivative be what's on top? Could it be a du over u? Well, let's find out. U is x cubed minus 3x squared, so this is my u. Du is 3x squared minus 6x dx. Is that on top? No, it's not. But if I take a 3 out, if I factor out a 3, now that piece is on top. It's right here, right? All I need to do is multiply it by 3. And I can do that if I multiply by a 1/3 out in front. So this has become 1/3 integral du over u. U prime over u. So that's ln absolute value u. So 1/3 ln absolute value, go back to my x's here for a multiple choice. So this would be a multiple choice answer. This would be a safe stop if you said that u was equal to that. Okay? Always have to say what u is equal to if you're going to say stop there. Okay, number 7. The bottom is not linear, so initially this is not an ln. So my question becomes, if I let u be the entire bottom, could its derivative be on top? Absolutely not, right? There is no way we can get an x cubed from taking the derivative of an x squared. Okay? So, if you have a fraction that is top heavy, meaning the power of the top is greater than or equal to the power of the bottom. Top heavy. If it's top heavy, we always divide. always divide. So I'm going to go off to the side and divide. So, well, normally I would go off to the side and divide. However, in this case, I'm going to do a quickie divide. We have a single term in the denominator, right? We have an STD, single term denominator. So I'm going to take care of it the quick way by applying it to both things on top. So this is the integral of x cubed over x squared, which is just x, minus 8x over x squared, which is 8 over x. Now normally I would bring that to the top and give it a negative power, but I'm not going to because it's linear. Now this little bottom is linear. Remember that we can take the integral of x, the first thing, minus the integral of the second thing, right? Right? So this is 1/2 x squared for the first integral minus, I don't have to do a u sub, it's already just an x. This is 8 ln absolute value x plus c. The 8 was on top, it stays on top. Okay? Number 8. Once again, we have a top-heavy fraction. So we divide. So I'm going to go off to the side and divide. I might get a different color here to divide this. All right. This is division where we can use synthetic division. It's not quickie because it's not a single term. It's not a single term. It's not. We don't have an STD this time. We instead, the bottom is linear, so we can use synthetic division. I'm going to go off to the side and do synthetic division. So I'm putting a -3 in the box for synthetic division, and I'm putting the coefficients of the numerator across the top here, including that 0 for the missing x squared term, right? And now we bring down the first number and then multiply that first number by the -3. So -3, and now we add. Multiply, add, multiply, add. Whatever is right here is our remainder. That's our remainder. So, our integral. It's important to note, you guys, that we have not integrated yet. All we did was divide. Our integral is now, we started with an x cubed, so we're down to an x squared after we divide out an x, minus 3x plus 7 plus -14 over the original divisor, x plus 3. Now we're going to go piece by piece and integrate each piece. So 1/3 x cubed minus 3/2 x squared plus 7x. Now we come to this piece. The -14 will stay. ln absolute value x plus 3. The derivative of x plus 3 is 1, so it's like we're dividing that 14 by 1 plus c. That's my thought. It's like we're dividing that 14 by the derivative of the x plus 3, which is 1. So that's just our answer here. Okay. Number 9. Once again, we have a top-heavy rational function as the integrand. So we divide. So I'm going to come off to the side and divide. Okay, I guess I'll pull out my colors again. Alright, this time I cannot use, it's not an STD, so I cannot use quickie divide. It's also not linear, so I cannot use synthetic. I need to do long division. So my divisor goes out in front, and my dividend goes inside here. Alrighty. What do we multiply x squared by to get x cubed? We need to multiply by an x there, right? So now I'm going to multiply this x by, I'm going to distribute the x through the x squared minus 5. So that will be x cubed minus 5x. I'm going to line it up underneath that negative 4x. And now we subtract. We're subtracting this polynomial minus this polynomial. So the x cubes are gone. We have that negative 4x squared. Negative 4x plus 5x is plus x plus 20. Now what do you multiply x squared by to get negative 4x squared? Well, you multiply by a negative 4, right? Now I'm going to distribute that negative 4 through these and write it here. So we will have that negative 4x squared plus 20. So I'm going to line it up underneath the other constant. And again we subtract this polynomial minus this polynomial. And I'm left with just an x. Since we would have to multiply by a 1 over x to get here, we're done with the division step. I'm going to go back to my integral. We have the x minus 4 plus the remainder. This is the remainder. The remainder over the original divisor. Okay? So now what? Well, the first two pieces, I know how to integrate both of those. In fact, I think I will go ahead and integrate both of those. It is 1/2 x squared minus 4x. But now we still have this to integrate. Oops. Okay. It's not top heavy. If it's not top heavy, I am going to let u be the entire denominator. Let u be the entire denominator. du then is 2x dx, and now we have the x dx there. All we need is the 2. So I'm going to multiply the front by 1/2. So we have 1/2 integral u prime du over u. So that is our natural log in the back there. 1/2 ln absolute value of u, where u is this x squared minus 5. So that was a lengthy one. Well, it was 4 steps, but it also had this division over there. Okay? So now is when integration gets really, really interesting and fun. Okay? Things are going to get jumbled at this point for you, quite likely, and if they haven't already. So we have to keep everything straight. You have to keep practicing. Okay? Keep practicing every day. If you want to be good at integrating, you have to practice all the time. Okay, so go practice.